So we now try to go through various vector operations that if you go through vector space, definition, subspace, dimension by classical approach, then you will find that it will take you much time to understand the jargons of the words. But we try to have common sense and try to understand vector space in Euclidean three-dimensional space, which will give you a very clear idea. What is dimension of vector? Number of vector is an ordered combination. Combination of how many entities are there in the combination, that is dimension of vector. There are many ways with which it can be expressed: linear independent, linear dependent. But what I try to keep the things simple, very simple. So vector addition we know. Vector multiplication also in dot and cross products we are aware of. We don't repeat that. What is important is somewhere that is our flow is that not all terms in the given module. Many times something becomes very tedious and what we can say quite boring. But we go through the basic crux, means linear algebra म्हणजे ते एवढं ते माहित पाहिजे किमान प्रत्येकाला. तर त्यातले जे ज्याला आपण कॉमन मिनिमम म्हणतो, ग्रेटेस्ट कॉमन फॅक्टर, त्या टाईपनं आपण जातोय. तर व्हेक्टर, सो आय होप दॅट you also contribute in the discussion. Vector, a very meaning, one is linear algebra. So linear is very important here. Now there is a well-known term called as linear transformation. You must have heard it. What we were in general in signal systems also you must have studied. DSP you have studied. What is transform? What is transform? And what is linear transformation? What do you understand from that? Any idea? Anyone? What is transformation? Okay, चलो बे. कमी करा पाहिजे म्हणजे आवाज कमी कर. हा पण घेतो तिकडे जायचं. So we will focus today on linear transformation and how eigenvalues are connected to that. What is so before that, what is transformation? Obvious, that is the meaning is one form to the other form. But which form? What exactly? What is transform? And transformation of vector. Anyone? Scaling. So if this is the vector, making it this much is called as scaling. So what happens in scaling? Magnitude increases, direction remains same. What is rotation? And magnitude remains. And translation? Both can change. But Listen very carefully. So, what we have got there, so the transforming operator has got an input vector and it results into another output vector. An input vector and output vector. So, what transform indicates? Transform indicates what is the relationship suppose that you like transform, there is a very similar example called a translation. Means a speaker talks in English, the audience doesn't know that, so there is a translator. So what translator is supposed to do? What is talked in English, you should translate into Marathi and again say it to the audience. But if it may happen so, that a translator may be mischievous. So what he can do, whatever he talks something else. Means for one input, he will deliver another one, but there is no connection between them. Are you getting me? There is no connection. So what kind of this transformation is called as? It's a random transformation. No relationship can be attached to the transformation. Actually, that random transformations also have got some meaning, because in that randomness also, if we go deeper, what happens in actual practice? What happens in actual practice? It is not that it is happening exactly as per the formula. There may be some kind of, when something happens in physical system, along with the defined, what we can say, multipliers, small changes, say voltage to current, resistance we say 100 kilo ohms, but it may be somewhat less or more. So a small element of randomness also attached. What actually we get is the defined transformation plus some random transformation. Only thing is that quantum is very less, so that effectively we can ignore that. Achha laga? Okay, now addition, not vector in general. 3 plus 5. What you get? 8. Is a definite transformation. Means that if numbers are 3 and 5, you will also get the answer as 8. It's a defined, well-defined transformation, but it is not one-to-one transformation. Means 3 plus 5 is 8. Similarly, 4 plus 4 is 8. So it is many to one. And when it is many to one, it is not invertible. When it is many to one, it is not invertible. Means for a given input vector, there is a definite output vector. But you cannot say, when given an input vector to you, you will find output vector. But given output vector, you are not in a position to exactly predict from which input vector it has come from. So there is a many to one correspondence. Especially when dimensions of output vector are less than that of input vector, it can't be one to one. If ever it has to be one to one transformation, in that case, dimensions of both sides should be same. Right? Means, listen very, very carefully. In Euclidean space, let us say this is origin. With respect to origin, I specify a point. So when the moment I specify a point, I specify ordered triplet. So a line connecting between origin to that point becomes the vector. Now this vector can be transformed. This vector can be transformed into another vector. So what I say, vector is a column vector. Is it right? in column, so what I can say, I'm trying my level best so as to keep the thing simpler for you. X coordinate, y coordinate, z coordinate, and this I will say as x1, y1, z1. It is the input, or x in I can say, one is alright. So x1, y1, z1, x1, y1, z1 is an input vector. Now, some kind of transformation will lead it into x2, y2, z2. So, what is ultimate transform? This point is mapped, this is input domain, and output domain, this point is mapped to some other point. Right? This point is mapped to some other point. Now, if ever this is to be 1:1 transformation. Now, listen very carefully. I am trying my level best. मराठीत थोडं सांगतो. ट्रान्सफॉर्मेशन म्हणजे काय? तीन एक आपण 3 डायमेन्शन मधलं सध्या घेऊया. 2 डायमेन्शन मधल्याची तशी गरज नाही. 3D मध्ये तुम्हाला सोपं पडेल. मॅम तेवढं समजा हे कळलं नाही असं वाटलं मला तर मी 2D स्पेशल सोपं करून सांगतो. एक कॉम्बिनेशन आहे 3 नंबरचं, ऑर्डर्ड आहे. 1 ऑर्डर्ड कॉम्बिनेशन ऑफ 3 नंबर्स, त्याच्यापासून आपल्याला एक ऑर्डर्ड कॉम्बिनेशन तयार करायचं आहे. की ते कसं करता येईल की ज्यामध्ये इन्व्हर्टेबिलिटी पाहिजे. आणि कॉम्बिनेशन करायचं म्हणजे आता एक सोपं करू शकता तुम्ही. x1 y1 z1 जे आहे त्याला तुम्ही 2x1 2y1 2z1 हे आहे का ट्रान्सफॉर्मेशन. x1 y1 z1 is input vector and x2 y2 z2 can be another vector which is म्हणजे काय पाहिजे, x2 y2 z2 हे ट्रान्सफॉर्मेशन जर मिनिंगफुल असेल, रॅन्डम नसेल, तर मिनिंगफुल ट्रान्सफॉर्मेशन मध्ये x2 y2 z2 हे ट्रान्सफॉर्मिंग ऑपरेटरवर आणि इनपुट वेक्टरवर अवलंबून पाहिजे. म्हणजे x2 y2 z2 हे x1 y1 z1 वर अवलंबून पाहिजे. मग आता त्यातलं एकदम सोपं घ्यायचं म्हणलं तर हे करता येईल ना.